All right, so 1.3 is on solving equations. So if you think about something really, really basic, like when you first learned equations in Algebra 1, okay? What you learned was that if you had something like x plus 3 equals 12, you read that in your head as some number added to 3 gives me 12. And that way you think, okay, well, what number do I need to add to 3 to get 12? I would need 9, right? So what you're doing is you're subtracting 3 from both sides in order to get the 9. And you do that in your head. You think in the opposite direction, right? Does that make sense? So when we're solving equations, we're going to do the opposite operation to get something to the other side of the equation, okay? So we're going to start out with some basics. So it says solve each equation, write solutions as simplified fractions if necessary. So we're going to add the 5.48 to both sides. Now, a lot of you guys are not going to need to show your steps anymore. Now that you're in Algebra 2, you're going to kind of do it quickly in your head, right? So if I have 5.48 plus 0.02, I'm going to get 5.50 or 5.5. So when I divide by 5, right, because I'm saying 5 times some number gives me 5.5, I get P is equal to 1.1. Now in the instructions I said write your solutions as simplified fractions. In general, if the original problem is in decimals, then your final answer can be in decimals. So I'm fine if you leave this as 1.1. But if you really were following directions and maybe you had some kind of online homework or something, you'll have that a lot in college, and it said write it as a fraction, then you would need to think of this as 1 and 1/10 or 11 over 10. Okay, that would be the simplified fraction. All right, so the next one, if I have 18 equals 1/2 t plus 4. Don't you guys hate when your math teacher uses t's? I always do like a little curly Q on the bottom. So I'm going to subtract the 4 and I get 14 equals 1/2. See how I draw my t's? They don't look like pluses. All right, so what I'm saying is half of some number gives me 14. That number is not 7. Do you guys see? Half of 7 is not 14. So what we have to do to get rid of the 1/2 is we are going to multiply by 2 on both sides. It gets rid of a 1/2. It's dividing by 1/2 is the same as multiplying by 2. So we end up getting t equals 28. Okay, so they get a little bit more complicated. This one involves the distributive property. So we're going to have 53 is equal to 3y minus 6. Now be careful. I always put questions like this on the test, and there's usually about 10 people that will get this one wrong. Because when they distribute, they do the negative 6y, but then they always put negative 2. Okay, make sure you're distributing the negative 2 times negative 1 to get positive 2. Okay. So from here, I like to think about the equal sign as being a brick wall. I'm not going to cross onto the other side of that brick wall until I've simplified everything on both sides. Okay, so I'm going to simplify the 3y minus 6y just like we did before, just like it's an expression. Okay, so I'm going to take 3y and negative 6y, and I combine those, and I get negative 3y. And I'm going to take the negative 6 and the positive 2, and I combine those, and I get negative 4. When people are not very good at algebra, the thing that they tend to do is they start subtracting. Like if they had, let me go back to that equation. They start subtracting on the same side of the equation. So they do things like this. Do you guys see why that's not right? It's not balancing the equation, right? It's like having a teeter-totter. Do you guys always do the teeter-totter when you're little? Like 4th grade, that was like all I did at recess. I played on the teeter-totter every single day of 4th grade. So imagine I'm balanced, and then all of a sudden, you know, one person jumps on this side, and then one more person jumps on that side. Like, that's not keeping things balanced. That's what you're doing with that equation when you do it on the same side. So that's why I always say keep it like the brick wall. Don't go on the other side until you're done. Okay, so we're going to add the 4 over, so we get 57. So negative 3y equals 57. And I divide by that negative 3. I don't add the 3, right? Because the operation between the negative 3 and the y is multiplication. And I get negative 19. So y is equal to negative 19. These types of equations, I'm guessing you feel pretty confident about, right? You got it. All right. So number 4. So same idea. So we're going to distribute the 3n. So we get 6x plus 75. We're distributing the negative 2. So negative 2x plus 2 equals 78. So be active note takers. Try this problem along with me. So kind of mostly look at your paper and try to solve it. So we combine our like terms. 6x minus 2x is 4x plus 77 equals 78. Now we're simplified on both sides. Subtract the 77. You don't have to show that step. We get 4x is equal to 1. So our answer is x equals 1/4. All right, the next one, we're going to distribute our 5. So I have 10w minus 15 plus, I'm distributing the 1/2, so 1/2 of 4, whoops, I don't know what happened there. 1/2 of 4 and 1/2 of negative 2. So I'm going to have 2w minus 1 equals 3w plus 12. Combine our like terms on each side. So I have 10w plus 2w is 12w. Negative 15 minus 1 is negative 16. So typically when I'm deciding what side to subtract the variables over to, I think about what's going to give me a positive number. I don't really like to deal with negatives if I don't have to, just in case I'd like leave it off. So I would subtract the 3w over, so that way I have a positive 9w. If you subtract the 12w on both sides, you get negative numbers. All right, so I have 9w minus 16 equals 12. Add the 16 over, I get 28. And divide, I get 28 over 9. And we leave it like that. We do not write it as 3 and 1/9. Leave it like that. Does that make you nervous when in your math books, if I gave you a question and all of a sudden you get like 28 over 9? It's a weird number. Are you worried about that when that happens? Don't be worried. Math in the real world is not always nice. Sometimes things don't come out perfectly. Like if I build a bridge, it's not going to be perfectly 100 feet. Sometimes we have decimals and so on, fractions. So in Algebra 2, we're starting to have weird numbers. All right, so the next one is very messy. Do you guys want to try it first?
Yes.
All right, go ahead and try it. All right, so your first step, when you simplify the inner parentheses, you should have 4 minus 8m minus 3 minus 6m inside there. Do we all have that part?
I was in the wrong one.
Yeah. I know I didn't leave much room, did I? All right, so now we're going to simplify what's inside the parentheses. If you didn't do that, that's fine. Some of you guys probably distributed the 2. That's totally fine. All right, so I'm going to have 7m plus 2 times 4 minus 3 is 1. Negative 8m minus 6m is negative 14m. So I have 7m plus 2 minus 28m equals 20. Do you guys have that? So check your paper. 7m plus 2 minus 28m equals 20. Maybe I made a mistake. Did I make a mistake? Let me know if I did. Get a bonus point, right?
I mean, I didn't see the parentheses at first.
Yeah.
Okay.
All right, combine your like terms. So 7 minus 28 is negative 21m plus 2 equals 20. Subtract the 2 over, you get 18. And divide by negative 21, and you have negative 18 over 21. I usually put the negative on top or off to the side, and that reduces, right? So on your homework, if I say write it as simplified as possible, you got to write it as simplified as possible. So divide by 3, so we get negative 6 over 7. That is our answer. All right, feeling good about that? Now in geometry, you might have seen some pretty simple ratios. You might have seen something like, let's say, 3 over x equals 4 over 7. If you have something like that, do you guys remember that we could multiply the 7 to the other side? We could multiply the x to the other side. Do you remember what that's called? Yeah, cross multiplication. So that is allowed because it's just doing like 2 steps in one, basically. It's multiplying the 7 that we were dividing before. It's multiplying the x that we were dividing before. That's what we're going to do on this one. Okay, so we are going to cross multiply. Okay, so when we do that, we're going to take the 3x minus 1 times 3. So we're going to have 3 times parentheses 3x minus 1. I need to remember to write parentheses, otherwise I won't distribute. Or you could just do it all together. Just some of you guys just write 9x minus 3. All right, and then we're going to do the 4 times 2x plus 5. So we get 9x minus 3 equals 8x plus 20. Subtract the 8x over, we get x. Add the 3 to the right side, and we get 23. So this answer is x equals 23. All right, and then we might have fractions. So just because we see fractions doesn't mean you just get scared and don't do the problem. I always say some of my students have fraction phobia. Does anybody admit to fraction phobia? Do you have fraction phobia? Yeah, a little bit. I have a phobia of spiders, and there was one in the faculty lounge during lunch, and I kind of freaked out a little bit. Nothing like doing that in front of your coworkers. All right, so you are not going to have fraction phobia after this year. We're gonna deal with that phobia, okay? So we're going to multiply the 5 over 7 in, and we're going to multiply the 3 over 5 in. All right, so when I do this, 5 over 7 times 14, I recommend kind of writing it to the side if you need to write it to the side. It's 14 over 1. We know that the 7 and the 14 reduce. So we get 5 times 2, which is 10. So if you need to write it off to the side, you can. Some of you are going to be able to do it in your head, which is totally fine. So the next one is going to be 5 over 7 times negative 21. So do you see how the 21 and the 7 reduce to be 3? Negative 3, really. So 5 times negative 3 is negative 15. So just do things one thing at a time. Are you guys getting good at it in your head? So the 10 and the 5 reduce to 2. 2 times 3 gives you 6, so 6x. The 15 and the 5 reduce to 3. 3 times negative 3 is negative 9. That equation is much better. Not scary at all, right? We can all handle this equation. So we're going to add the 15x over. So we get 10 equals 21x minus 9. I add the 9, I get 19 equals 21x. So I get x is equal to 19 over 21. I divide the 21. No, because see how the 21 is attached to the 19? I'll show that step because sometimes that's confusing when it's backwards. So yeah, 19 over 21. Okay, good so far? All right, so what if you have a whole equation full of fractions? Like these ones.
Man, I just keep reading that.
You just cry. You cry. All right, so there are two ways to do these problems. There is what I call the long way, and then there's the short way. And of course, like every teacher, I'm going to show you the long way first, and then I'm going to show you the shortcut. So we're going to do the long way for this. So if I'm doing it the long way, I keep the fractions the whole time. So if I want to combine my x's, I'm going to add my 1/2 x to both sides. So I'm going to have my 3/4 equals 5/8 x, or not 5/8 x, 5/8 minus 3/4 x plus a 1/2 x. And I say, oh, I need to combine those x's, so I need common denominators. I added it to the other side. So I'm going to multiply by 2 over 2 so that I have my common denominators. So I'm going to have 3/4 equals 5/8 minus 3/4 x, I'll write it out, plus 2/4 x. So when I combine my x's, what do I get? Ah, careful, one has a negative. Negative 1/4 x, right. So I'm going to have 5/8 minus 1/4 x equals 3/4. Now I want to subtract the 5/8 over. Okay, so if I'm doing that, I want to get common denominators with the 3/4. So how am I going to rewrite 3/4?
6/8.
Yeah, it's really 6/8, right? So I'm taking my 6/8, I'm subtracting the 5/8 over to the left side, and I'm left with my negative 1/4 x. So I get a 1/8 equals negative 1/4 x. So just think about it logically. Negative 1/4 times some number gives me 1/8. What will I need on the denominator? 2, right? What will I need on the numerator? Not just 1, though. Negative 1, right? So I end up getting negative 1. But the reason is because I'm dividing by negative 1/4. which is the same as multiplying by -4. So I end up getting -1/2. That's a lot of steps. So clearly there has to be an easier way, right? Because that wasn't even a long equation. There were only 2 terms on both sides to begin with. And I can give you things that are crazy, like number 11, for instance. I can make it really, really hard on you. So there has to be an easier way. So who knows the shortcut method? What do we do? Yeah, what do you think?
Multiply return by the least common multiple.
Yeah, the least common denominator. So we look at all of the denominators and we say, well, I have a 4, a 2, and an 8. If I have a 4, a 2, and an 8 on the denominator, if I multiply through by something that clears it, then I'm good. Because as long as I'm multiplying on both sides of the equation, I'm keeping it balanced. I'm back to that teeter-totter. Okay, so I'm going to multiply through by 8 on both sides of the equation. So I'm starting with my 3/4 x minus 1/2, or sorry, I keep writing the x where it's not. So 3/4 minus 1/2 x equals 5/8 minus 3/4 x. And I'm going to multiply the left-hand side by 8, and I'm going to multiply the right-hand side by 8. So we're multiplying by the least common denominator. If you want to write yourself a little note, multiply by the least common denominator. So when we do this, we're going to clear our fractions. So I have 8 times 3/4. Now, like I said, some of you guys are going to get very good at doing this in your head.
6.
It is 6. So again, if you need to write it off to the side, it's 8 times 3/4. What we're thinking is the 8 and the 4 reduce and become 2. So I have 2 times 3. Now, if you think about what we're literally doing with fractions, though, if we're taking 3/4 of 8, well, let's think about it. If I have 8, what's a fourth of 8? 2. So what's 3 of those fourths of 8? 6. Does that make sense? So think about it that way, too. So we get 6. So we're going to have 6. Well, what's 1/2 of 8? 4. So we have 6 minus 4x equals 5/8 of 8. Well, an eighth of 8 is 1. 5 of them is 5. Right? 8 times negative 3/4. Again, if you need to do 8 over 1 times negative 3/4, you can. We get negative 6x. Much, much easier now. We've cleared those fractions. So let's add the 6x over. So we get 6 plus 2x equals 5. Subtract the 6. And divide. And our answer is negative 1/2. We good? So let's do another example, and then I'll let you try number 11. What am I going to multiply number 10 by? 12. So sometimes I get lazy and I only write it on one side of the equation. Really what I'm doing is I'm multiplying it on both sides of the equation, right? So if you see me put a parenthesis around the whole equation, that's what I'm doing. All right, so I have 12 times 1/2 is 6x minus, how good are you at doing this in your head now? It is minus 10, right? Because 12 divided into 6 pieces would be 2 each times 5. All right, the next one is going to be 7 minus 3x. So when I add the 3x, I get 9x on the left. I'm going to add the 10 over, I get 17. So my answer is x equals 17 over 9. That's it. All right, you guys want to try number 11? Start it out. See if you can get that first step at least. Okay, check your first step. Did you get 11x minus 10 equals 18 minus 9x minus 8?
That's exactly what I got.
All right, so thumbs up if you got that. I only see Olivia with a thumbs up. Oh, maybe. Oh, yes, yes. Ethan has one. Okay, good. The rest of you have questions? Do you need me to walk around and help you?
So does the 36 at the bottom cancel out?
It's not really like 30, oh, like in the first one? Yeah, because it was 36 times 11 over 36. So those reduced out like that. Because it's like 36 over 1, right? Yeah, like if you're multiplying through by the least common denominator, on that second step, you will never have any fractions. Like that's the reason we do that, to clear those
So where
fractions.
does the 6 go on 9? Does the 6 go?
Like over here, like the 9x. Which-
No, on number 9. The 6.
Where did the 6 come from?
Like how'd you get 6?
Oh, this one?
Yeah.
Okay. I got the 6 by doing 8 times 3 over 4.
Oh, okay.
So it's like,
Yeah.
does that make sense?
X equals 13, 12.
All right. He says 13 over 12. Did you guys get that?
Yes, I got that.
I don't know. You're the one that said it. I was just going with what your answer. Let's see.
Oh,
So we have 10 minus 9x.
okay, yeah, I got it.
Add the 9 over. We get 19x. I don't think it's 13 over 12.
I minus.
Yeah.
Oh, if I add 9 and 11 correctly, I would have that. Did we get x equals 1?
Yeah.
That is correct. Yeah, so we added the 9x over, added the 10 over. Yeah, 20x equals 20. All right, do we see mistakes if you got it wrong? You get it? All right, let's try 2 more. Now, these ones are a little bit different. So these ones are different because we don't have like individual fractions. Okay, so this is kind of a tough concept for students to understand. So the way that my Algebra 2 students typically like to do this is they like to go ahead and distribute first. So that way it's set up exactly like those last ones. Okay, so we can do that. Yeah, go ahead.
I was going to ask if we could type this into the calculator, but the X.
Yeah, the x, yeah, you wouldn't be able to. All right, so we're going to have 2x minus 4, and then I have negative 5, 6 times 3. So again, if you need to do negative 5, 6 times 3 over 1, you can do that. It reduces 1 and 2. You get negative 5 over 2x plus 5 over 6 equals 5 over 4x minus 1/4. Okay, so now it is set up exactly like those last ones. So if I was going to get rid of my fractions, what would I multiply by? Look at the denominators. I have 2, 6, and 4. Bigger than 6 because I wouldn't get rid of the 4. 12, yeah, the least common denominator, you can write LCD, is 12. So we are going to multiply both sides of the equation by 12. Keep it balanced. So it starts out easy enough. 12 times 2 is 24. So I have 24x. And then I have minus 48. How about the next one? 12 times negative 5 over 2. Negative 30? Did I hear 40? Negative 30. All right, so negative 30x. And then plus, all right, 12 times 5 over 6. Well, what's 1/6 of 12? 2, right? So what's 5/6? Right, 10, exactly. All right, 5/4 of 12. So let's divide it into 4s. 12 divided by 4 is 3. So if I have 5 of those, I'm going to have 15. And then minus 3. Evan, you got it? I saw a confused look. Maybe. Okay. Maybe like a sign error or something. All right, combine your like terms. 24 and negative 30 make negative 6x. Negative 48 and positive 10 make negative 38 equals 15x minus 3. We're going to add the 6 over to the right side. We get 21x. We're going to add the 3 over to the left side. We get negative 35. So negative 35 over 21 is kind of our answer. They're both divisible by 7, though. So we get negative 5 over 3, exactly. Okay, so you can do the problem that way. So, and that's usually what most of my Algebra 2 students like. They like to distribute first and then clear. Or you could clear originally. But if you're clearing originally, remember that if you have, let's say I have the numbers 2 times 3. If I multiply that all by 4, do I multiply by both the 2 and the 3? No, if I have 4 times 2 times 3, I get 24, right? It's not the same. We don't do that. It's not 8 times 12. Do you guys understand what I'm saying? So if I multiply the whole thing by, whoa, gosh, it moved. If I move the whole thing by 12 originally, then this whole term, 12 times 1/2 times 4x minus 8, I just multiply here. I don't multiply into the parentheses. Do you understand that concept? I get the 6, and then it's all times the 4x minus 8. Okay, so that's what's tricky for Algebra 2 students. They sometimes want to multiply into everything. So it's kind of tricky. All right, so let's do 13, and then we'll be done for the day. All right, so if I'm multiplying the 3/4 in, 3/4 times 6, that's a little bit harder. You need to reduce, right? So I'm going to have 3/4 times 6 over 1, reduce, 3 over 2. I get 9 over 2. X minus 3/4 minus 1/6 of 3 is 1/2 x minus 2/6 is 1/3 equals 3/4 x minus 1/4. This is as hard as I get. What do I multiply by to clear my fractions? 12. Yeah, so we're going to multiply through by 12. I'm going to do this kind of quickly. 12 times 9 over 2 is going to be 6 times 9, so 54x, minus 12 times 3 over 4 is going to be 9, so minus 9, minus 6x minus 4 equals 12 times 3 over 4 is 9x. 12 times negative 1/4 is negative 3. So I get 54 minus 6, 48. Negative 9 minus 4, negative 13. 9x minus 3. You guys trying this, Manish?
Oh, yeah.
Do you have the correct answer? What is it?
9.
You're not writing. I just assumed you had it. All right. So subtract the 9 over. So I get 39x equals 10. Is everything all right there? Did I get that all right? So x is equal to 10 over 39. All right, so that's the very last one. All right, so we'll stop there. Now, I'm not doing all of the notes. We're still going to talk about this next time, but I'm still going to pass out your